Hi, in this video, I will explain about the X-ray spectrum. When an X-ray tube operates, the fast-moving electrons which are released by the cathode will collide with the target element. These collisions cause photons of X-ray to be emitted at different wavelengths. The various wavelengths of X-ray photons produce, forming a spectrum. The X-ray spectrum consists of continuous spectrum and characteristic line spectrum. Some of the electrons that colliding the target element are decelerated and stop in a single collision. This type of collision causes photons of X-ray with a minimum wavelength to be emitted. But majority of the electrons are decelerated and stop after few collisions with the atoms of target element. In each collision, a fraction of energy of the electron is converted into a photon of X-ray. The fraction of energy which is converted into X-ray photon differs from different electrons. This situation causes photons of X-ray emitted with different wavelengths. This different wavelength of X-ray photons forming the continuous spectrum. When the voltage between cathode and anode is increased, few lines of high intensity occur. These lines are called as characteristic line spectrum. There are two types of characteristic line spectrum, K-series and L-series. K-series line spectrum consists of K-alpha and K-beta, while L-series line spectrum consists of L-alpha and L-beta. This K-alpha, K-beta, L-alpha, and L-beta have specific wavelength for every element. When an electron collides with an atom of the target element, it could excite the electron in K shell to a higher energy level. If an electron from L shell drops into the K shell to fill the vacancy, a K-alpha photon will be emitted. If an electron from M shell drops into the K shell to fill the vacancy, a K-beta photon will be emitted. When the electron that colliding the target element excites electron in the L shell to a higher energy level, an electron from M shell or N shell may drops into the L shell to fill the vacancy. This causes a L-alpha photon or a L-beta photon to be emitted respectively. There are a large number of target atoms that experience this type of transitions. Hence, the intensity of this characteristic line spectrum are high. Thank you very much.